Okay, moving into 2.2 today, we're going to be solving inequalities. And the beautiful thing about solving inequalities is that you basically know how to do it already, because you already know how to solve an equation. And then based on what we did yesterday, you already know how to graph the solutions. In case we have forgotten, I have put the steps to solving an inequality, which, like I said, is very similar to solving an equation, up top. The first thing you are going to do is make sure that each side of the inequality is simplified. So that means if there's parentheses, we're going to distribute. If there's like terms on the same side, we're going to combine those. Simplify the left and the right side of that inequality symbol first. Once you do that, you are going to gather all of your variable terms. So get all variable terms on one side of the inequality sign. Now, when we did equations, I said, I always like to bring the smaller one to the bigger one, so you can go left or right. It doesn't really matter. Well, I'm going to encourage you that when it's an inequality, to always move to the left side. So if you can remember, always move to the left side. That way your final answer will always be x first. Like x is less than 3 or x is greater than 3 or whatever. That way we don't graph it wrong. Does that make sense? So when we move all of our variables, let's go ahead this time and just move them all to the left. Once again, if you don't, it's okay, but then you'll have to do that thing like we did today where you have to turn it around at the end. Okay? After you have all of your variables on the left side, then we are going to undo that constant. So we will use addition or subtraction to remove the constant. And then our last step will be to use that multiplication or division to remove the coefficient of x. So once we have all of our variables on that left side, we'll undo the constant and then undo the coefficient. All those steps are just like equations. Now, here is the one thing that we need to highlight. This is a big, do not forget this. Right here, this little note that I'm about to tell you. Is that in step 4, if your last step, if you multiply or divide by a negative number, if in that last step you multiply or divide, which normally it's going to be divide, by that negative number, the inequality sign is flipped. So in order to keep the inequality true, we're going to have to flip the sign. So if it was a greater than, we're going to flip it to a less than. Or if it was less than, we're going to flip it to a greater than. Okay? And we'll have some in our practice, so you'll see what I mean. Here we go. We've got 5 inequalities that we're going to solve, and then we're going to graph the solution. Number 1, starting off nice and easy. We're going to draw a line down that inequality sign, just like we did with equations. There's not an equal sign there anymore. There's an inequality symbol, but same thing. The beautiful thing about this problem, there's no parentheses. There's no like terms on the same side. We already have all of our x's over here on the left. So we only got 2 steps to solve this. We're going to undo the constant and then undo the coefficient. So if this is a plus 36, I'm going to remove that by doing the opposite. So I'll subtract the 36. So I get 2x is greater than 24 minus 36. Negative 12. Very good. Thank you, everybody. And then now the last thing I have to do to get x by itself is divide by 2. So my x is going to be greater than negative 12 divided by 2 is negative 6. And now that I have solved, I can graph that. So I would have negative 6, and then negative 5, negative 7 over here. based on what we talked about yesterday, hopefully we know that on -6, we're going to have an open circle. And then since it is greater than, we are going to go to the right. All right, let's look at number 2. Number 2 is another easy one because there's no parentheses. There's not x's on both sides of that inequality symbol, which means all I have to do is undo this constant and then undo the coefficient. So since this is a +7, I'm going to subtract 7 so that I have -3x is less than or equal to 21. Very good. And then my last step is going to be to divide by -3. And the fact that I'm dividing by a -3, this is when those sirens need to be going off in your head, because this one thing that I told you you have to remember up here is that when you divide by a negative, you have to flip that inequality sign to keep it true. So now, all of a sudden, x is going to be greater than or equal to 21 divided by -3 is -7. It's still a negative. All right, so now that we have the correct solution, hopefully the graphing part is easy. On -7, our circle is going to be closed, and since it's greater than or equal to, we are going to the right. All right, number 3, we're going to increase the difficulty just a little bit, because now all of a sudden we've got some parentheses. So the first thing we need to do here when we see these parentheses is distribute that 4 to both of those terms inside of the parentheses. So 4 times x is going to be 4x, and 4 times 12 is, very good. So I have 4x plus 48 is less than 18. Now all I have to do, undo this constant and then undo the coefficient. So since this is a +48, I'm going to subtract 48. (4x) is less than 18 minus 48 is -30. And this won't be beautiful, but that's okay. So now we just have to divide by the coefficient. So we're going to divide by 4. And we get x is less than -7.5. Yes. We divided by a +4. We only flip it. This is a great question because I know Cameron was not the only person that went to flip this sign. We divided by a +4. This number was negative, yeah, but the number we divided by was positive. So we only flip it. See in number 2, the number we divided by, the number on the bottom of the fraction was negative. So if the number on the bottom is negative, that's when we need to flip the sign. We don't care about the number on the top. Okay? Only if the number you're dividing by is negative. Does that clear up a little bit? Okay, good. All right, one more with me, and then I'm going to be trying number 5 with your partner. Number 4, again, increasing the difficulty a little bit. We do have parentheses, so let's go ahead and distribute that 3 first. So 3 times the 3x is going to be 9x. And then 3 times the 5 will be 15. And then I'm going to bring down what's on this other side. So is greater than or equal to -x plus 45. this is the first one where now we have x's on both sides of the road. So we need to collect all of our x's to the same side. And again, I like to always come to the left on an inequality so that my final answer will always be x is blah, 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 then something. So since it's a negative x over here, how do I move it to the other side of the road? Add it. Very good. So I'm going to do plus 1x on both sides. So that I have 10x now over here because now these are like terms on the same side and I can combine them. So 9 plus 1 is going to be 10x. Then I'm just going to bring down the plus 15 is greater than or equal to 45. Now that I have all my x's over here on the left, I'm going to get all my constants on the right. So since this is a plus 15, we're going to subtract 15. 10x is greater than or equal to 45 minus 15 is 30. Which then my last step to solve for x there is divide by that coefficient. So I'll divide by 10. And I get x is greater than or equal to 3. So I make my number line with that 3 in the middle. On 3, I'm going to have a closed circle, and I'm going to shade to the right. All right, last one, number 5. You and your partner are going to work together. I'm going to give you guys about, 2 to 2.5 minutes. Yeah, ready, go. Let's look at this problem and see how you did. X is less than or equal to 17. I did give you guys the hardest one to do with just your partner. You know, we did all the easy ones together, and then I gave you a hard one. But these steps are very similar to just like solving an equation. So we just did a whole unit of this. When you distribute the negative 5, you should have gotten negative 5x plus 30. So everybody make sure that math is correct if you didn't get this 17. Then you're going to distribute the negative 3. So that's negative 3x minus 21. And then I bring down this other extra third term over here plus x. So now this is the first one where you had these like terms on the same side. So when I combine those, negative 3 plus 1 is negative 2. So I have negative 2x minus 21 on the right. And then on the left, I have the negative 5x plus 30. Now, like I said to you at the beginning of the notes, I like to always bring my x's to the left when it's an inequality so that at the end, I don't have to worry about trying to turn it around before I graph it. So if this is a negative 2x, to bring it over to the other side, I'm going to do the opposite of a negative 2x, which is a plus 2x. So I add 2x's to both sides so that I've got negative 3x plus 30 is greater than or equal to negative 21. Now I undo the constant, so I subtract the 30. I get negative 3x is greater than or equal to negative 51. My last step is to divide by the negative 3. And again, those sirens go off in my brain because since I divided by a negative number, I have to flip the sign. So x is less than or equal to 17. Questions on that one? Gonna give people about 30 more seconds to finish making sure they have the right work on their notes. All right, we're going to go ahead and go on to the second page. So we've got now some application problems. Starting with number 1, it says, Jan needs to buy a backpack and several folders for school. If she shops at Target, the backpack will cost $50.40 and folders cost 15 cents each. If she shops at Walmart, the backpack will cost $45 and folders cost 45 cents each. Use the inequality given to complete the statement below. So yes, they've given us this whole story problem about going to buy school supplies, but they've already given us the inequality. So what we're going to do is we're going to solve this inequality and then be able to fill this out. Jan would need to buy more than or less than of blank folders for Target to be less expensive than Walmart. So that's why we've got this Target expression is less than the Walmart expression. Solving it, the first thing we're going to do is collect our x's on the same side. And again, I like my x's to always come to the left so that my inequality is easier to graph. So I'm going to subtract the 0.45x. And I know I'm going to get a negative, which I hate, but I hate turning around the inequality even more. So I had to pick the lesser of two evils. So I'm going to bring down the $50.40. And then what do I get now that these x's are on the same side? What do I get when I combine those like terms? Negative 0.3x. And then that's less than what I have left over here, which is the 45. So now that I have all my x's over here on the left, let's bring the constants on the right. So since I have a positive $50.40, I'm going to subtract it. So now I have negative 0.3x is less than 45 minus 50.4 is negative 5.4. Then my last step here to solve for x is going to be to divide by that negative 0.3. And because this number on the bottom is negative, because I'm dividing by a negative, sirens are going off in my head and I'm flipping the inequality sign so that it's x is greater than, what's negative 5.4 divided by negative 0.3? Very good, 18. X is greater than 18. So now that we have found that solution, it should be really easy for us to complete this little statement. She needs to buy what? More or less? More, because it's a greater than sign. So she needs to buy more than the 18 folders for Target to be less expensive than Walmart. Okay, last one. Luna opened an account with $50 and she plans to deposit $15 each week. Every time we see those words each or per or whatever, those are very important. On the same day, Mason opened an account with $10 and he plans to deposit $25 each week. Write an inequality to represent the number of weeks. So guys, this number of weeks, that's our variable, right? That's going to be our x. So our x better go with the numbers that are talking about every week, each week, per week, whatever. So write an inequality to represent the number of weeks that Luna's account balance will be greater than or equal to Mason's. So that word problem made it very easy for me to know what inequality symbol I got to use. It literally said greater than or equal to. It didn't say like at least or at most or blah, blah, blah. Greater than or equal to. So we are writing an inequality that's going to be when will Luna's account be greater than or equal to Mason's? Now let's talk really quick because not all of us have bank accounts. If they're depositing money each week, what are they doing? No. They're adding. When we deposit money, we're putting money into an account. We're adding to the money that's already there. Withdrawal is when we take out. Yes, so if we're depositing money, we're putting money in. And you guys said adding, so you better have some plus signs in your expression, right? So Luna started with 50, and she's adding $15 each week. And the number of weeks is what we're trying to figure out. So how would we write that? Prem. Beautiful. 50 plus 15x, and we want to know for how many weeks is that going to be greater than or equal to Mason, who only started out with $10, but he's adding more every week. So eventually he's going to have more money than Luna in his account. So what did he start off with? 10, and he's adding 25 per week or each week, so plus 25x. Okay, that's it. All we had to do is write that one. If we needed to solve it, we could, but we don't need to.